Ecosystems around the world are facing many threats, from climate change to overfishing. Statisticians like Dr Francis Hui are developing tools to better model these growing threats and scientifically understand their impacts.
If an ecologist has gone out and surveyed a bunch of sites and they've sort of collected data on a whole lots of species in an ecosystem, I'm interested in trying to form models to try and analyse all those species at the same time. This is a much bigger challenge, but it's also a much more important challenge because it allows us to sort of answer questions that we weren't able to answer with just studying a single species.
Two of Dr Hui's major research areas in statistics are latent variable modelling and dimension reduction. These models are able to reduce responses from potentially hundreds or thousands of species down into a two-dimensional space. This space is made up of key patterns inferred from data known as latent variables. In statistical ecology, these variables represent how species are interacting with each other and how the diverse ways they respond to the environment are similar or differ over space and time.
And this allows us to give something that is much more interpretable, but at the same time is something that is sufficient to be able to capture the richness and the complexities in all that data.
Dr Hui's research is also about making these statistical models better at analysing even richer and more complex data.
As the data sets increase in size and increase in volume, it's trying to find ways of fitting these latent variable models in a computationally efficient and scalable manner. It's future-proofing them.
And the applications of his research are wide-ranging. Recently, he collaborated with colleagues in Chile to look at ways of improving the country's sustainable fishing policies. They found that a uniform policy across such a large geographical space wouldn't work, but a separate policy for each fishing cove would also be too impractical. With latent variable modelling, they reached a middle ground, grouping together coves with similar distributions of fish and potentially a similar response to policies. This paved the way for a more adaptive and flexible fisheries management system. Dr Hui has also applied his research to fields like mental health, where he's built statistical models to study long-term questionnaire data.
The beauty of statistics is that it's kind of in a way, kind of a universal language. You get to play in everybody's backyard.
Dr Hui has been awarded the Christopher Heyde Medal for his contributions to statistical methodology and their applications.